Okay, so your specification goes on to talk about specific energy system changes that you need to know about. I'm just going to read this section from the start of the specification section that covers this. So it says, a system is an object or group of objects. There are changes in the way energy is stored when a system changes. Students should be able to describe all the changes involved in the way energy is stored when a system changes. For common situations, for example, an object projected upwards, a moving object hitting an obstacle, an object accelerated by a constant force, a vehicle slowing down, and bringing water to the boil in an electric kettle. So the first one then, an object projected upwards. So a typical scenario could be that an arm is throwing a ball up. So in the arm, you've got the chemical energy stored in the muscles, haven't you? So chemicals stored in muscles. So then there's a force exerted, yeah. So the force exerted mechanically, that's the transfer, yeah, because it's a force. It's mechanical. Okay, the force is extended mechanically and it does work. So anytime there's an energy transfer, work is done. So it does work, converting the chemical energy store in the muscles to a kinetic energy store in the ball. Oh, kinetic energy. Okay, so we've got chemical store. Yeah, chemical store, mechanical transfer, kinetic store. That is our first typical scenario. The second one then, a moving object hitting an obstacle. So that could be a car hitting a tree, for example. So if the car is moving, yeah, so we've got a car hitting a tree. So the car's going to be moving first. Sorry, my drawing is awful. So car hits a tree. So before it's hit the tree, the car is going to be moving, so it has kinetic energy stored, isn't it? Yeah, so the kinetic energy is stored. It's then going to hit the tree with a contact force, so that's force, isn't it? So the clue there is there's a force going on, that's going to be mechanical then, isn't it? It's a normal contact force, yeah, Newtonian physics, normal contact force. So work is done to slow the car down. So what's going to happen? The tree is going to move away from the car as it hits into it, but then it's going to bounce back. So that's elastic, isn't it? Elastic, because it's deformed, but it's gone back to its original shape. So elastic potential energy. There's also going to be a bit of heat involved, isn't there? So thermal energy. Now, lots of you are going to say, hang on, there's going to be a sound too, but you'll remember from the energy transfers that sound is a wave, so that's going to be out of this system, isn't it? So we might say sound transfers energy away from the tree and the car. So we've got kinetic energy store, we've got going to elastic potential and thermal energy stores. And work is done mechanically. I didn't write it in, so mechanically by the normal contact, by the car hitting the thingy, the tree. Okay, so that's where the energy transfer is taking place. Right, an object accelerated by a constant force. So we could have a what are we going to have? So a typical scenario then could be something falling to earth, so it could be a ball, or your common example is actually a skydiver. Sorry, my drawing is terrible, but skydiver falling to earth, yeah? So the constant force then is gravity, yeah? So energy store at the start is gravitational potential energy. Because the skydiver is above the Earth's surface. Okay, the force of gravity does work. Mechanically. And we're going to get then kinetic energy. Okay, so gravitational potential is stored at first. Kinetic energy is stored in the end, and the work is done mechanically. Even though the force is not a contact force, it is still involving forces. Fourth one then, a vehicle slowing down. So we have got the kinetic energy store of the wheels, haven't we, in the vehicle slowing down. So we've got a car braking, decelerating. So kinetic energy of the wheels in the wheels. The brakes apply a force, which is friction. So that's work done mechanically. And then we are going to have the thermal energy store. Okay, thermal energy store in the brakes. Yeah, the brakes are going to heat up, the wheels are going to heat up. So our energy store starts off kinetic, ends thermal, and again we're transferring mechanically. So all of these sort of real world examples with big objects, they're all mechanical, they are all involving some sort of force. So the way you could be asked questions about them, you might have to work out what force is involved in there. You might even have to draw on some forces, okay? Because even though it's a paper 1 question, this sort of thing could come up in paper 2 because it so heavily involves forces. This last one then is your kettle heating water, bringing water to the boil. So we have got, now I almost said electrical energy there, so I made the mistake that we don't want to make, okay? So we've got chemical energy in the power station or wherever, yeah? So chemical energy is stored in the power station, which is then transferred electrically. That should just be one arrow through. Electrically to the thermal store. Yeah, the thermal store of the kettle's heating element. The thermal store of kettle's heating element. And the way this works is that the heating element is going to have a very high resistance wire running through it. So the high resistance is going to mean that it's going to heat up, right? So the thermal store of the kettle's heating element, and that is then going to transfer energy by heating, by conduction, to the thermal store of the water. And the thermal store of the water that's directly in contact with the heating element is of course then going to expand and move up. So rise because it's less dense, so that's also going to be heating by convection to heat all of the water. Okay, so we've got chemical store in the power station, thermal store, the kettle's heating element, thermal store of the water. You could potentially say there's another store going on because the water molecules will be moving, but I'm just going to make that small because it's not necessarily one you need to come up with. But your transfers, electrical, and then we're going to have heating, okay, so conduction, convection. So those are your typical energy transfers within systems that you need to be aware of. Then goes out to say that students should be able to calculate the changes in energy involved when a system is changed by heating, work done by forces, or work done when a current flows.